Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called The Confetti Incident by Dying Flutchman. I hope the setter is not really dying, but either way, I guess I know it's playing off of Flying Dutchman, but I really hope it's not. I hope dying is not actually describing the setter here. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We have disjoint groups rule, where digits may not repeat in the same position in different boxes. So, for example, if, say, there was a 5 here, that means in the upper left position of every other box in the grid, you cannot have a 5. So there are no repeats in the same positioning in a box for for the boxes. I guess is a way to put it. And that's an example of how disjoint groups works. We also have little killers, where digits along the diagonal arrows sum to the indicated total. So, for example, these 2 digits add up to 17. These 3 digits add up to 20. These 5 digits add up to 39. And these 8 digits along here add up to 53. And that's how little killers work. And then finally, we have killer cages, where digits in cages do not repeat and sum to the indicated total. So for these two add up to 17. For example, if we had a 6 here, this would have to be a 9 here, because these 2 digits must add up to 15. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We know any 2 digits that add up to 17 must be an 8-9 pair. So this is 8-9. This is 8-9, 8-9. 8-9, 8-9. This must be a 6 or 7 here, because we have an 8-9 pair in the box to add up to 15. So this is 6 with 9 or 7 with 8. So this is an 8-9 pair here. Okay. These 3 digits add up to 14 without an 8 or a 9. What's the most you can have for 3 digits? 5, 6, 7, which adds up to... Okay, so you can't have 5, 6, 7. The most you can have here, then, would be 7 with 4 and 5. Interesting. We have... Okay, that's interesting. We have 2 8-9s already in the upper left-hand position in these boxes. So the rest of the boxes cannot contain 8 and 9 in the upper left-hand position. That doesn't really tell us much. So this cannot be 8 or 9. It could be 3 through 7. These could be both 8 and 9, but you cannot have a 3 here. If this is 3, that would only be with 8 and 9 in the rest of the diagonal, but that's not allowed. Okay. These cannot be 8 and 9, so we have 1 through 7 here, 1 through 7 here. That means these are, we have 1 through 7 in row 4. We have 1 through 7 in column 4. Okay, and this is 6, 7, 8, and 9, but we don't know which one is which. So we know these are different 8 nines. So this is blue. This must be, we'll make that pink, so this must be pink here, which makes this blue here, and this must be blue. um, hmm. Okay. Blue cannot be here, cannot be here. We don't know which one of these is which. Blue cannot be here or here, but blue could be here. To add up to 39, you cannot have 8, 9 here. So this is at most 16 plus 9. 16 plus 9 is 25. Plus 7 and 9 is what? So 16 plus 9 plus 7 and 9 would be... That would be 41, right? So 7 plus 9 times 2. Can it ever be 7, 8 is the question, right? So say this is 7, 8. That would mean this is 9. So this could not be 9. So that would be 7, 8, and 8. And you could potentially have 7 and 9 here. So 7 and 8 is 15. Plus 8 is 23. Plus 7 and 9 is possible. Okay. So that is possible. But the max is 7, 9, 9, 7, 9. Which would be 41. So we have 2 degrees of freedom along this diagonal. So that means the 7 here could go down to a 5. We have 7 and 9 here, which could go down to, so it could be down to a 5. This is 9 going down to potentially a 7. And then 9 going down to an 8, I think. I think it has to be an 8 or 9 here, right? If we tried going down more than that, 7 and 6, plus 9, plus 7 and 9. So 7 and 9 is 16, plus 9 is 25, plus 6 and 7 is 13, which adds up to 38 at most, which is not allowed. Okay. How many degrees of freedom do we have here? That's interesting. This is at most 6 and 7 here. So 6 and 7 here. This could technically be 7 and 9. Can it, though? No, it cannot be 7 and 9. If this is 7 and 9, this adds up to 20, but it adds up to 20 without 7 and 9, but that would be 5, 6, and 8 at most then, which adds up to 19. So it cannot be 7 and 9. This is 15 at most then. Because the rest, so this adds up to 20. This adds up to at most 10. That's 30. So this is this adds up to at least 10, which means this is 15 at most here. So we have 15, 13. Um, hmm. Okay, what happens if we try to make this 9, blue 9, right? If that's the case, that means all the blues are 9. So this would be 6. This would have to be 7, 8 at most. This would be 8 at most. So this would be 7, 8 as a pair. And this would have to be 7 and 9. Um, right? 16 plus 8 is 24 plus 15 is 39. So 7 here would force this to be 8, which makes that 7 here. 8 eliminates 8 here, so it's 9 and 8. Okay. That seems reasonable. This can't be 7, 8, or 9, so it's 6 and 9, which makes this 8 and 9. Or not 9, 8 here. Okay, it does kind of work. Um, hmm. But what does that mean for this diagonal is the question, right? Um, neither of these can be 9. Ooh, that's interesting. So this cannot have a 9 here, which forces this to be, I believe, a 5, 7, 8 triplet here. So this is 5, 7, 8. Obviously, 8 cannot be here. This can't be 5 and 7 then. This can't be 6. This can't be 6. This is at most 6 here. So this can't, okay, this is at most, this can't be 7. This is at most 6. This is at most 5. This is at most 6. Again, we could have 6 and 7 here. This is not 6 or 9, but it could be 8. And then this is at most 6 and 9, I believe. Okay, so this is the most you can have along this diagonal if we had a 9 here. Does that add up to 53 is the question. We have 15 plus 8 is 23 plus 13. 23 plus 13 is 36 plus 6, 36, 42, and 53. So that is possible. It is possible. Interesting. Huh. I was hoping that would lead to a contradiction, but it did not. Hmm. This cannot be 7. If this were 7, the problem is this would have to be a 6, 9 pair. So you have 7 there, you lost your 2 degrees of freedom. And then you cannot, this is 6 and 9, so this has to be 7 and 8 at most, which you've lost another degree of freedom, so you can't add up to 39 anymore. So this has to be 8 or 9, which is the pink one. So this cannot be 8 or 9. This is 6 or 7, which adds up with 8 or 9 to add up to 15. So this is the blue one. This cannot be 8 or 9 here. Can you ever have this without 8 or 9 here? I think the answer to that is no, right? Say you have 6 and 7 at most. You've just dropped the 9, 3 amount, which is not the degree of freedoms we have. We have 2 degrees of freedom at most. So you cannot drop the 8, 9. So this has to be 8, 9 here, which makes this pink, which makes this blue, which makes this pink here. Um, Interesting. Okay. Can this be all pink? Potentially, right? Blue cannot be here, so blue has to be one of these two. Blue has to be one of these two, and blue has to be one of those two. Blue can't be here, blue can't be here, blue can't be here, so blue's one of those two. Pink, cannot be here. It's one of these four. So blue cannot ever be part of this diagonal. So it cannot be 3, 8, 9. So that means the pink one has to be one of these two. We don't know which. Interesting. So it's either 4, 7, 9, 5, 6, 9, or 5, 7, 8. Can we not have an 8, 9 here is kind of a question, right? The remaining digits in row 7 are 1 through 7. Remaining digits in row 6 are also 1 through 7. So are these digits. 53. So this is 1 through 7. 1 through 7. This could be 8 or 9. This could be 8 or 9. Okay. We have one in the upper left corner, one in the upper central, one in the lower, left central, one in lower central, one in the upper right. So we have the pink at 8, 9 in all of these positions. This can't be the blue 8, 9 because we already have a blue 8, 9 in that position. So this must be blue 8 and 9 here, which means this can't be blue 8 and 9 here. So this is blue 8 and 9. And either of these could be blue 8 and 9 here. So we know this is definitely blue 8 and 9. This is definitely blue 8 and 9. That's interesting. These could be either one. We don't know. Pink 8, 9 is one of those four. Pink 8, 9 is one of those four. And pink 8, 9 is one of these four. So that's not helpful. Can you have this 14 without the other 6 and 7? I believe the answer is no, right? If you don't have 6 or 7 here, the most it could add up to 3, 4, 5. So you have to have the other 6, 7 here, which means the other digits in this box are 1 through 5. Can you have a 5 outside? Yes, 3, 4, and 7 does add up to 14, so that's possible. How many degrees of freedom do we have in this diagonal here? Um, hmm. 7, 9, 8. That's 24. 6, 7. So 24 plus 13 is 37. Plus 7 is 44. Plus 13 is 57. We have 4 degrees of freedom here. Interesting. Okay. 4 degrees of freedom, which means you can never have a 1 go here, right? So let's just double check. 7, 9, 8 at most, right? Because blue cannot be here, so you can't have double 9s here. But pink could be here. So then you could have 9, 8, and 7. That's 24 plus 6 and 7. 24 plus 7 is 31, plus 6 is 37, plus 7 is 40. Wait, hold up. Wait, what? That doesn't... 24 plus 13 is 37, plus 7 is 44. Okay, yeah, 44 plus 13 is 57. So the 6 could go down 4. So 1 cannot be here. The 7 here could go down 4, so that's a 3. Again, no 1 here. This potentially 8 could go down 4. So 4 through 8, this can't be 1. That's all we know. Okay. This could be 9 here too. Hmm. We are guaranteed a 6, 7 here. Okay, this is the... Let's make this orange and blue, adding up to 15. So we have the orange in the lower right, orange in the upper right. So that means we need an orange in the central. So it has to be either here or here. If it's here, that means this adds up to 15, and this would add up to 20. So this would be 1 through 4, which is still possible. Or it could be here. We just don't know. Hmm. Oh, that's interesting. That you cannot have. So okay, if you have 6, 7 here and 6, 7 here, this can never be 6 and or 7 here. So you're guaranteed that has to be a 5, if that's the case. Because you can only have 6, 7 in both of these positions in the same way, right? Interesting. Um, hmm. Because you could have 6, 7 here, or this is 7, 6, but then the other one has to be 6, 7 this way. So then this is guaranteed to be 5, if that's the case. So realistically, this then loses 2 degrees of freedom. So we do not have 2 or 3 available. We do not have 4 and 5 available. This can't be 2 or 3. This can't be 2 or 3. Is that really the case, though? We could potentially have... Oh, that's interesting. Right, so if you look at it this way, then... This is 5, 6, and 7 along this diagonal. So it's 5, 6, 7 plus 5. This is 5, 6, and 7 adding up. That's 18. You could have 6, 7 here. That's 33. And you could have pink, blue, and you still could have a 3 here. So 5, 6, 7 is 18, plus 6, 7 as a possibility here. Huh. That's 18 plus 13 is 31. Oh. Okay, so yeah, 31. And these are different, guaranteed. So this is 17 at least, at most. So 53 minus 31 is 22. 22 minus 17 means this is 5 at most. Say you had a 7 here and a 9 here, or 7 and 8. So again, you have 5, 6, 7 along this diagonal, specifically in the left central cells. You have, oh, this is 5, 6, or 7. So you don't even have that. You have 4, 6, 7 guaranteed. Because this is 5, 6, 7 because of the limitations along this diagonal. And since this is 5, 6, 7 limited, this is 4, 6, 7 at most. So this can't be 5. This is 6 or 7 here. Interesting. So we're going to mark that with as a green 6, 7. That means the rest of column. So the green 6, 7 has to be one of these. The rest of column 3 is 1 through 5. Interesting. So again, you have 4, 6, 7 at most in the left central cells. You still have 6, 7. That's 4, 6, 7. That's 17 plus 13 in the upper central cells. So that's 17 plus 13 is 30. That leaves 33 remaining in these 3 cells. So I think that has to be 6, 8, 9. So this is, I think this has to be the pink 8, 9. Because if you try to have 7 with another digit, so say this was, you can't have 7, 7 because they're in the same position. So if you try to have, you can't have 7, 6. Oh, you can't. This is 6 and 7. So that eliminates 6 and 7 here. If you try to go down from this being 8, say, to 5, you have 5, 7, and 9 at most here. That's 21. 21 is not enough with 4, 6, and 7 on this left central cells, and then 6 and 7 with the top central cells, because that adds up to 51. So this has to be the pink 8, 9. which eliminates the pink 8, 9s here and here. So this has to be the pink 8, 9 here. This cannot be 8, 9. That means pink 8, 9 cannot be here. Pink 8, 9 cannot be here. Pink 8, 9 cannot be here because it's already in the central cell. So this is not pink 8, 9. This is blue, which makes this pink. So this is blue 8, 9. This can't be blue 8, 9. This has to be blue 8, 9 here. This can't be pink 8, 9, so this is the other pink 8, 9. Okay, we still need an orange 6, 7. Where is it going to be? It has to be in... We have it already in the upper right corner and the lower right corner. We need it in the central right position. And it cannot be central right here or here. It can't be central right here or here, so this is the last central right, 6, 7. That means the pink cannot be 8s. If the pinks are 8s, then this is too small, right? You have 8, 7, 8, 7, which adds up to 30, plus 8 is 38. That's too small. So the pinks have to be 9. So we know the pinks are 9. Do we have all of them? 1, 2, 3, 4, 5, 6, 7, 8, 9. The blues are 8s, and the oranges are 7. That leaves the greens as 6. This has to be, to add up to 14, it has to be 3, 5, and 6. So this cannot be 7. Therefore, we know this is a 5, 6 pair, adding up to 20 here. This cannot be 5, 6, or 7, so this is 4. We've lost a lot of our degrees of freedom here. This cannot be 3 or 5. Because of the 3, 5 set, 6 adding up to 14. This can't be 4. No 4 or 7. This can't be 7. This can't be 6. So 9, 9, 9 add up to 27. If this were 5, that doesn't work because 5 and 6 add up to at most 11. So 27 plus 5 and 6 adds up to 38 at most. So this can't be 5. This is 7, which forces this to be a 5. So no 6, 7 here. This is 5. Okay. No 5, 7. No 5, 7. Here, no 5. This can't be 7. This can't be 7 here. No 6, 7. Rest of this box 5 is 1 through 5. One of these two is 4, so this cannot be 4. Where is the 4 in row 3? It has to be here. Let's just clear all this out. There's a lot of information here that we don't need. Okay, 5, 6, 5, 6. We have 1, 2, 3. We have a 3, 5, 6 triplet in row 3, which eliminates 3, 5, 6 in the rest of the row. This can't be 3. This has to be a 1, 2 pair. That 1, 2 pair eliminates 1 and 2 in the rest of the box, so this is 3. Okay, what do we have along this diagonal? We have 4, 8, and 9. That adds up to 21. Plus 6. 21 plus 6 is 27. 53 minus 27 is 26. And this is 6, 7 at most, 6, 7 at most. So this must be a 6, 7 pair. So this is 6, 7, 6, 7. This 7 eliminates 7 here, so this is 6, which makes this 7. That eliminates 7 in the left central boxes, so this is 6, which makes this 7. Okay. And now it's probably just mainly Sudoku. Oh, this adds up to 11. Huh. Um, so obviously this is 1 through 5 here. This can't be 3 because of 3 in the column. This could be a 6. It could be 1, 2, 3, 4, and 6. So how do you add up to 11 with these digits? You could have 2, 4, you cannot have, there's no 7 involved. We know where the 7 is in row 1. It cannot be here because of 7 in the box. Can't be here because 7 in the box. Can't be either of these because 7's in the column, so 7 has to be here. That gives us 8 sevens, so we know where the last... No, that doesn't give us 8 sevens. One of these two is 7, one of these two is 7. But this can't be 7 here because of the disjoint set, so this must be 7 here, which forces this to be 7 there. So that should, we have all the 9s, we have all the 8s, we have all the 7s. 6s is still pretty, okay, so 6 eliminates 6 here. So this is 5, that's 3, and this is 6, which makes this 5 and makes that 6. Okay, so that tells us a decent amount. This can't be 5. Remaining digits in column 2 are 1, 2, and 4. Okay. How many 6s do we have? So 6 cannot be here in box 8 or here, so 6 has to be one of these two digits here. Which means where is the 6 in column 5? Cannot be here because these are filled, and that's a 6 in this row. Can't be here because 6 in the box. Can't be here because 6 in the row, so it must be here. 6 in row 4 has to be one of those two. And then 6 has to be one of those 3. What about 5s? 5 is one of these. So this is 1, 2, 5 as possibilities. This has to be 1, 2, 3 as possibilities. Okay. We have a 6 in the central box, so this cannot be 6 here. We have a 6 in the lower right corner, so this can't be 6 here. Therefore, this must be 6 here. We have a 6 in the upper central box, so this can't be 6 here, which forces this to be 6 and that to be 6. So we should have all the 6s. This does not have a 6. You cannot have 3 unique digits adding up to 11 with just a 1, so this has to be without 6, 7, 8, or 9. So this must be a 2, 4, 5 triplet. And 5 can't be here or here, so this is 5. This becomes a 2, 4 pair. That leaves this as 1 and 3. This can't be 3 because of 3 in the column, so this is 1, that's 3. This is 1, 2, or 4 remaining. We have a 1, 2, 4 triplet in column 3, so this must be a 3, 5 pair. Okay. 5s. 5 cannot be in the upper central box for disjoint sets, so this can't be 5, therefore this is 5 here. 5 can't be in the left central cell, so this can't be 5 here. 5 can't be here, 5 can't be here, so this must be 5 there. 5 cannot be in the lower right cell, so this can't be 5, that's 3, which makes this 5. 5 in box 5 cannot be here, cannot be here, can't be here, so it must be here. That gives us 8, 5, so we know where the last 5 has to be. It has to be here. Okay. 1 has to be one of these two. This becomes a 2, 4 pair here. This has to be 2 and 4 also. This must be a, what, 1, 3 pair here. This must be 1 or 2. We have 1, 2, 3, 4 remaining, so this is 2 or 4 here. 1, 2, 3, 4 here. 1, 2, 3, 4 here. And one of these is a 3. Okay. 3 cannot be the lower cell of a box anymore because of this 3, so this is not 3 here, which forces this to be 3 here. 3 cannot be the left central of a box, so this can't be 3, which forces this to be 3 here. So 3 has to be one of these two. Where's 3 in box 4? Cannot be here, so it must be here. So that eliminates 3 here, so this must be 3 here. This has to be 1 or 2 because we already have a guaranteed 4 here as one of these 4. We have a 1, 2 pair in column. Okay, this 3 eliminates 3 here, so this is 1, this is 3. This 1, 2 pair eliminates 1 and 2 in the rest of the column, so this is 4, that's 2. That eliminates 2 in the lower right cells, so this is 4, which makes this 2, which makes that 4. So this can't be 4 anymore. This 2 eliminates 2 here, so it's 4. That means this can't be 4 here, so this must be 4 up here. This 1 eliminates 1 here, so it's 2, 1, 2, 1, 2, 1, 2, 1, 2. That leaves this as a 2. This cannot be 2. This 2 eliminates 2 here, so it's 1 and 2. That means this can't be 2. We can't have 4 in the central cell, so this is 1, that's 4, which makes this 1 and that 4. Well done. Hope you had fun. And don't forget to keep fletching. Okay. Yeah. Fairly straightforward. You just have disjoint sets, and then you have the constraints of the little killer clues, which does constrain things, and you can work that with the obviously the disjoint set rules to make some restrictions, and that's what led us to the solution. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.